So we have talked about the concept of solving equations, and what we're going to learn about today is the idea of solving absolute value equations. Let's start first with what is absolute value. Absolute value, by definition, if you recall, is the distance that a number is from zero. So if I use the proper absolute value symbols, which are the two vertical lines, and I ask you what is the absolute value of 5, I'm asking you how far from 0 is 5, and the answer to that is 5. Similarly, if I asked you what is the absolute value of negative 5, that is also 5, because negative 5 is 5 units from 0. So absolute value essentially is basically always positive. Absolute value is always positive because distance is positive. If I asked you how far below the water you have traveled, if you are 50 feet below, even though that could be represented as negative 50, you still are 50 feet. That is the distance from the water surface. Absolute value is always positive. And this is going to be a very important concept when we go through the remainder stuff with absolute value equations. As a quick little review, if we think about the concept of equations, if I gave you an equation like 2x minus 5 equals 2 minus 5x, in order to solve it, you recall from last lesson that you bring all the x's on one side, and you get 7x. You rewrite what doesn't change, equals negative 2. Add 5 to both sides, and you get 7x is equal to 3. And then you divide by 7, and you get x is equal to 3/7. This here is one solution. There's only one answer to this equation, because that is the only thing that gives me the value of x. We know that there are also opportunities for no solution or all real numbers, and we're going to talk a little bit more about that with absolute value equations in a little while. So now that we recall the difference between, or what absolute value is, and we recall how to solve equations, we're going to talk a little bit more about the group of absolute value equations and how to solve them. So notice that 4 and negative 4 are 4 units from 0. The absolute value of x, if I ask you, what is the absolute value of x if it is equal to 4, then you know that what you're asking for is what number is in there, so that when you take the absolute value, it gives you 4. Well, if we know that absolute value is the distance from 0, and we know that whoever is on the inside of this absolute value sign, whoever's on the inside, whatever value that x is in there, whatever value this is, he is 4 units from 0, then I know that this on the inside could either be 4 or negative 4. Because if x was equal to 4, the absolute value of 4 would give you 4. But that's not the only solution, because x could also equal negative 4. And if that was the case and you plugged that back in, you also got 4. Essentially, absolute value always has the potential for 2 answers. Absolute value has the potential for 2 answers. When you're solving absolute value equations, that's the reason why it's very important to remember that absolute value, there's always 2 cases that you have to consider. The first is that the inside is the positive value, and the second is that the inside is the negative value. The important rule number 2 that we're talking here is that once you get an answer, you must check it, because it is possible that one of those 2 answers is not a true solution. And we'll talk a little bit more about that in a second. And the third rule is you have to remember that when you take the absolute value of any number, whatever it is, that's always going to give you a positive. So if you have, as one of your original questions, what is the absolute value of x, and it gives you -5, you know that this is not possible because nothing taken the absolute value gives you a negative. So if you ever get something that looks like that, where you're asked for the absolute value of something and it says that it's equal to a negative, then you know that that's no solution. So let's get some work started so that we can get an idea of everything. At this point, it's okay if you're a little confused, but just walk with me for a second. Take, for example, this question. We know that the absolute value of whatever f plus 5 is going to give me 17. That means that this on the inside can either be equal to 17, because the absolute value of 17 is 17, or can be equal to -17, because the absolute value of -17 is also 17. That means that you have to set up the inside into two possible scenarios. The first is that your inside absolute value, which happens to be f plus 5, that whole thing is possible that it equals +17, so that when you take the absolute value of it, you get 17. The other option is that that is going to give you, that f plus 5 could possibly yield the value of -17. Because if this whole entire f plus 5 is equal to -17, if this whole thing is -17, the absolute value of it is also 17. So these are the two cases that you can have when you are beginning to solve. Case number 2 and case number 1, where case number 1 is saying the absolute value of the equation could give you a positive number, and case number 2 is saying that it could give you a negative. So let's take this one, for example. If I know that the value of f plus 5 has to equal, after you take the absolute value, 17, then I know that this on the inside could equal the value of 17. So step 1, set it up equal to the positive, f plus 5 equals 17, and then set it up equal to the opposite, -17. When you continue solving, you solve like a regular equation, but now you just have two equations in one. You get the value of f is equal to 12, and on the right one, you minus 5, you get that the value of f could equal -22. These are the two potential solutions. In order to check to see if it is the solutions, I have to take these and put them independently back in. So if I know that the original question says the absolute value of f plus 5 gives you 17, then I'm going to try this here and plug it in to f. 12 plus 5. That gives me 17. Is the absolute value of 17 17? Yes. So I know that one of my solutions is an answer. One of the answers is a solution. Now I need to check this work. Does -22, when you plug it back in, does it give me that same 17 when I take the absolute value? Well, let's see. If I plug that in there, it's going to get the absolute value of -22, which is the f, plus 5. We want to know, does that give me 17? Well, -22 plus 5 is actually -17. The absolute value of -17, does that give me 17? Yes, it does. So I know that not only 12, but -22 are my solutions. And again, the reason that these are the two solutions is because there are two numbers that when you plug them in here and then you take the absolute value of them, you get 17. And to graph them, you're literally just putting dots on 12. So let's say that 12 is here. It is to the right of 0. Let's put there. And then if we go to negative 22, let's see if we have enough tally marks. So if we were going back this way by 2s, we're going to have 12, 10, 8, 6, 4, 2, 0. 0, 0 is right here. And then we go back, negative 2, negative 4, negative 6, 8, 10, 12, 14, 16, 18, 20. 22 is like right there. So let's make a little extra tally mark there. And we're going to name that negative 22. And that's a solution. So this here is the graph that gives me the solution of 12 and negative 22. Okay, so now let's look at the examples. Remember, when you're doing absolute value, because of the fact that absolute value is the distance a number is from 0, and it's always positive, then you know that the inside of the absolute value, which I'm going to refer to as A, so whatever is on the inside, and remember, it doesn't have to be the letter A, it's actually anything inside of the absolute value. So if I change this so that these are my absolute value symbols, anything on the inside of the absolute value, if that is equal to a value, whatever that is, then I know that the A itself can either equal positive B or it can equal the negative of B. And so my job is to set up two equations. Let's start with letter B. Let's look at this. Can the absolute value of anything equal a negative? No. What this is saying is that whoever's on the inside, once you take one away from it, and after you take the absolute value of it, you are going to get a negative? That's not possible. You can't do this. So this is no solution. There is no number that when you subtract 1, whatever you get, after you take the absolute value, it'll give you a negative. So this type of equation, which I refer to as this, if that's what's on the inside, the absolute value of anything, if it is equal to a negative, it's no solution. You can't do that. The definition of absolute value is that it is always positive. And so if you're telling me from the original written work that the absolute value of something is a negative, you can't do it. There's no solution. As opposed to this one. In this case, it's telling me that the absolute value of x is 3. Yeah, you could be positive 3, because 3 is positive. So case 1 is that x could equal 3. Case 2 is that x would equal negative 3. And if I was to graph it, it would look like this. Negative 1, negative 2, negative 3. Okay, let's look at the bottom part. It's a little bit more complex. So I'm going to keep these up here, specifically so that you guys can see that when you take the absolute value of anything, whatever is on the inside, and it gives you the positive, which is the proper way. If it has this from the beginning, your job is to break it up into 2 and then solve each independently. And if you have the absolute value of anything giving you a negative, you know it's immediately no solution. So let's look at this one. First, is the absolute value by itself? No, I can't do anything until I get the absolute value by itself. So the first thing you're going to do is divide by 4 like you normally would to get the absolute value expression by itself. That gives me 6. Is it positive? Yes. So now you break it up into your two things. Case number 1, the inside could equal positive 6 Case number 2, the inside could equal -6. Solve your regular equations. X could equal 4 minus 2 on both sides. X could equal -8. So the way that we would write our answer would be that the solution set for this is, that means the answers, and we use braces instead of parentheses, 4 and -8. This here is what we refer to as the solution set. And so that's how you would write your answers. This is the solution set. The reason we use braces instead of parentheses is because parentheses, if you remember, would tell you a point, x comma y. And so we do not use parentheses, we use braces. The braces tell you that there's 2 answers and that those answers are 4 and -8. For the next question, remember, you should always make sure that you isolate the absolute value first. So I'm going to write this at the very beginning. The very first step should always be to isolate or get alone the absolute value part first. And you simplify basically by doing this. So in this case over here, if you look back up to this question, before we did the 2 different cases, we had to divide by 4 to isolate x plus 2, which is within the absolute value. Here, you have to do 2 things. You've got to bring this 2 over. So we're going to isolate first, so you minus 2 on both sides. And you get negative, because the negative is still there. Don't forget that part either. Negative absolute value of 2x minus 5 is equal to 5. We are still not completely isolated because there is a negative here, and we just want absolute value of something. So in order to get that undone, you multiply this whole thing by -1, or if you want to think of it in terms of divide by -1, it's understood that there's a -1 there. Or even still yet, if you know that the negative of that 2x minus 5 absolute value is 5, then you switch the direction of the signs. So to get rid of this, you can either divide by -1 on both sides, and that leaves you 2x minus 5 within the absolute value is equal to -5, or you just flip the direction. If this one was negative and this one was positive, you just flip them. But before you can continue, you've got to remember the huge, most important thing, which is that the absolute value of anything cannot equal a negative. So in the process of solving it, if you get, in the process of simplifying, the absolute value of 2x minus 5 equals -5, you know that this has no solution. Don't discriminate. Okay, let's look at this question. Step 1, simplify. And in order to simplify, what does that mean? That means that you isolate, get alone, the absolute value expression. Whatever is on the inside of the absolute value sign, you have to try to get it alone. So for letter C, -6 is being added to the absolute value. This -6, if you, maybe it helps to think of it this way, -6 plus x. If you treat this whole thing as an x is equal to -6, you're going to want to bring him over. In the same method, you are going to look at it this way and say, how do I get -6 alone? Well, here's my equal sign. I'm going to add 6 to both sides. That's going to leave me with the positive absolute value of x minus 4 is equal to 0. Now, don't immediately think that because it's equal to 0, there's no solution. Remember, you can have a number equal to 0. 0 are numbers too. So zeros can be solutions. Step 1, set it up equal to the positive. So you take x minus 4, you set it equal to 0. and to the negative. Well, the negative of 0 is just 0. So if you were to write this, that would make no sense. So really, these two mean the same thing, so you don't have a second case. Add 4 to both sides. Solve your equation. X is equal to 4. And check your work. Yeah, you could plug 4 in there. 4 minus 4 is 0. The absolute value of 0 is 0. And negative 6 plus 0 is negative 6. So your solution set is just 4. And again, remember how we write solution set. We write it with braces. 4 is the answer. You don't write x equals 4 necessarily, even though it's not totally incorrect. You use the solution set braces. Okay, let's look at this word problem, which I know it's going to be a little confusing, so just be patient with yourself as you're going through and paying attention to it. The temperature of an enclosure for a pet snake should be about 80 degrees Fahrenheit. Give or take 5 degrees. Write an absolute value equation to find the maximum and minimum temperatures. Think of it this way. If you think of it like the following, you think about, well, I know that it can be 80 degrees, but you can be higher than 80 or lower. So in reality, the temperature that you can be, if you take away the 80 degrees that you should be at, you're going to either be positive 5 or negative 5. So whatever your temperature is, whatever your, case 1, whatever your temperature is, take away the 80 degrees, that's going to give you a 5-degree difference. Case 2 is that whatever the temperature is, you take away the 80 that it should be at, and it's going to give you a difference of negative 5. The absolute value equation is this one, and your two cases are, first of all, x minus 80 equals 5, and second of all, x minus 80 is equal to negative 5. Solve the two like normal. Your temperature could either be 85 degrees or your temperature could be 75 degrees. So the solution set would be 85 degrees or 75 degrees. And that would be the answers, which we refer to as a solution set. So these questions are a little bit more difficult. They're asking you to write an absolute value equation that would give you those two solutions. So the first thing is we figure out what are the solutions. Okay, 11 and 19. 11 and 19 are your answers. We know that 11 and 19 are both equally distanced from the middle of, which is 15. 15 is right here. 11 is 4 units less than 15. 19 is 4 units more. So we know that the distance is 4 units, so that's what the absolute value is to equal. And the inside is going to be whatever number you have. If you take away 15 from it, you're going to get, and then after you take the absolute value, you get 4. 11 minus 15 is negative 4. The absolute value, that is 4. Same thing with the one on the right. 19 minus 15 is 4, and the absolute value of 4 is 4. So the way to figure this out, if you guys remember stem and leaf plot, or box and whisker plot, basically, remember when we did interquartile range? The median between the two numbers is the number that you subtract from the variable within the absolute value, and that's going to give you the distance that each of the numbers is from the median. So this here is the equation, the absolute value equation for that graph. Similarly, here's 17 and 26. Your job is to figure out who is the middle number. Well, to find the middle number, you can either count Or you can find the average between the two. It's basically 27 plus 17 divided by 2. 27 plus 17 is 44, divided by 2 is 22. So now I know that 22 is the middle number. 17 is 5 less than 22. And 27 is 5 more. They're both 5 units away. So this is 5 units and this is 5 units. That is the absolute value because that's the distance. The equation would then be the absolute value of x minus 22. So you take x away from 22 and then take the absolute value of that, and that should give you 5. Now, we're not going to have a lot of these, but it is important for you to understand how it works, or at least to understand where that comes from. Okay, now the independent practice, we will work on them when you come to class, but I'm going to give you a quick little summary just to make sure you remember if you want steps of what to do. When you're solving absolute value equations, if you are to want to look at some steps, what you would have to look at is that the very first step that you take is that you isolate the absolute value. What that means is that you are trying to get the absolute value alone. You're going to isolate whatever the absolute value expression is so that it just says equals a number. So everything on the inside of the absolute value is what I refer to as the A. The next thing that you're going to do is to make sure that B, or the answer to the absolute value sign, is not negative. What this is saying is that if you have something like the absolute value of something is equal to a negative, then you know that this is no solution. And then the next step is to set up the two different cases. If the absolute value of A is equal to B, then the two different cases are the positive and the negative of B, which would be that the A could equal B, but the A could also equal the negative of B, because once you take the absolute value, it is positive. So the two different cases are the positive case and the negative case. Remember that if from the very beginning your absolute value expression is equal to a negative, then you know there's no solution. But once you have that absolute value of the expression set up equal to the positive B, if that's what you get, then you could break it down into the two different cases, and then the very last step is basically just to solve for each. And when you do solve for each, remember that the way that you write your solution set is to use braces. So your solution set uses braces. So if your answer is 5, you would write the answer 5. And the other number if there's more than one, and sometimes there will be just one, and sometimes there will be no solution.